Hello, everyone, and welcome to this latest webinar from IHS Markit. My name is Alan Tatara, Senior Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. Today's webinar is Intent-Driven Networks Maximize Business Value via Automation. IDN can bridge the gap between business intent and network implementation, providing the network automation that telecom operators seek. So today our panel will explore the techniques and architectures behind intent-driven networks and provide use cases for their deployment. Our webinar is co-presented by IHS Markit and our partner Huawei. So before we get started, I want to highlight just some features that are available for you on our webinar and how you can then make the most of your experience today. So the console that you're looking at is completely customizable. So you can open, close, move, or even resize any of the windows that you have open on your screen and arrange the console to suit your preference. Now at the bottom of your console are a number of application widgets. Make sure you check these out. One button I do want to mention is the resource list widget. And this is where you will find additional material about today's topic, including the downloadable slide deck from today's session, as well as other valuable resources. And we do want to make this an interactive session, so we've included a Twitter widget at the bottom of your screen, and this means you'll be able to tweet directly from the console. And today we're using the hashtag IntentDrivenNetwork. We will also have a live Q&A session directly after this presentation, so please remember that you can submit your questions or comments at any time by using that Q&A box on the left side of your screen. And if you do encounter any technical issues during the webinar, just click on that question mark widget and you will get the answers that you need. So now let me introduce our panel. First leading our discussion is Dr. Clifford Grossner. Cliff is Senior Research Director and Advisor in the Cloud and Data Center Research Practice segment at IHS Markit. And rounding out our panel, we have Alan Hu. Alan is Senior Director of the Router and Carrier Ethernet product line at Huawei Technologies. So welcome to both Cliff and Alan. It's great having you with us today. So let's get started with our presentation. So Cliff, I will turn it over to you.
Well, thank you, Alan, and thanks to the audience for taking time out from a busy day to hear what we have to say. I hope you're going to find it enlightening and you will learn something important. I'm going to start off by talking a little bit about the market and how automation is an imperative for 5G, and I have a little bit of a treat for everyone. I have some results from a survey we did of 14 experts working in the area of edge computing. And then we're going to talk a little bit about why SDN in its original form was not enough, and what we really need is to layer on top of SDN some automation achieved through a closed loop, and also injecting some artificial intelligence techniques and machine learning. Then our sponsor Huawei will talk a little bit about their approach for intent-driven networks and how that's imperative as well to achieving automation. And then we'll go through some deployment examples and wrap it up with a few short conclusions. So with that, let me push on to talk a little bit about the market and how we got to where we are today. And we're all aware, I believe, those of us that are listening, that we started looking at the concept of SDN and NFV more than 5 years ago, maybe 7 or 8 now. And the idea with SDN and NFV was to bring the concept of a cloud architecture to the telco, putting functions into software, and then being able to orchestrate services very dynamically. And with that required the ability to simplify the network, bring networks together, make them flatter, also make it a bit invisible whether it was a fixed network or a wireless network, and also be able to allocate slices of the network so that we could, as we reconfigured services, also drive a certain user experience. And it was very clear partway through the process of doing SDN and NFV that without automation, it was not going to be possible. There were just too many levers that needed to be pulled in real time that no human could actually either set static policy or make that happen. So we then came up with the idea of, well, let's introduce artificial intelligence techniques for inference, which could work in real time, leverage machine learning to help with inference and create closed loops automation across many domains. And with that, we then move to the concept of digital transformation, bringing all of that together, where we have the carriers looking for new type of customer interaction, services delivered on request through a portal in a matter of seconds, not a matter of days or minutes, moving into what we would call the online era, if I can use maybe a bit of a dated term. And all of it is going to be key to automation and intent-driven networking will be part of that process. However, there is one gotcha, and what I wanted to share with the audience is something that Bill Gates said, which I think is still extremely current, is that if you have an inefficient operation, and we all know that a lot of telco networks had lots of room for improvement, automation will only magnify that inefficiency. We can only apply automation to an efficient operation, and if we do that, it will make it more efficient. So it's very important that we tidy up, if I may say, before we create, before we try to automate. And then what I want to talk a little bit about is edge computing. And what I wanted to share with everyone is that with the edge comes a lot of promise, but also a lot of technology challenges. And with the edge, compute becomes highly distributed, and the fact is there are many edges. There's the IoT edge, which is potentially in the cell site gateway or an IoT gateway. There's not an edge, which is at the data center, not near a CO, so central DC. There is a partial edge, where we have an edge near the CO in a regional data center. And the conclusion we make is there's also an edge in the smart CO and mini DC, is that there are many edges. And the fact is there's also an edge with UCPE equipment being placed on the customer prem. And then we have servers now moving out to the edge for mobile connect and processing of data locally, and also at the CO and regional data centers on top of UCPE. So at the end of the day, we have to serve. There are many opportunities because there are lots of new low latency locations for serving applications. And we also know that there's already over 20 billion devices connected as of last year. And the sheer volume of data that's going to be collected at the edge, in some sense, makes aggregating that all in the central data center not possible. So it means that we now need to apply compute at the edge locations to aggregate, abstract data, potentially decide to take an action locally. And then also we can use the edge locations for saving bandwidth from some central location to the edge by doing an intelligent form of caching. So, and for our definition, what we look at is anything that is less than 20 milliseconds response time from the user would be considered an edge. Now, interestingly, many people ask, well, what are the top edge services? And it turns out that what we heard from the panel of experts that we interviewed, that video and the search for immersive technologies such as AR and VR are the top drivers for the edge compute. And even though there are hundreds possible, we got lots of answers, in order to create this result for you to see visually, we grouped a number of areas together. So within the video area, which we saw 92% of respondents talked about in aggregate, that we had video content delivery, which included 360 video and immersive experience in venues, stadiums. And there's no surprise here that video and immersive experiences are the top app, because if you look at apps like YouTube and Netflix, they today make up a large part of the web content already, and are expected to hit over 82% of total web content by 2021. Now, in order to meet this need, Service providers have already been slowly re-architecting their network, moving certain functionality to the edge. So it's not that there isn't an edge today. What's going to happen over the next 5 years or more is that the compute at the edge is going to multiply, and we'll see as many apps will become enhanced with new experiences. And the carriers, the telcos, have an advantage because they already have many locations like central offices and cell sites that are already within a few milliseconds of the end user. What's going to be needed for some of the other applications that we see listed here, like AR, VR, like autonomous vehicles, like IoT and gaming, we will need to have that compute in those locations. Now, with that being said, even though we know what we want, we have a number of challenges ahead. As we also asked the same panel, what were the hurdles? And it looks like both technology and high cost are top hurdles that we that have been identified. And some of the sub-elements are that many apps are going to require new software that hasn't been written yet. There are APIs that we're looking for to allow developers to write code once and run it in many locations. And we'll also need to manage hundreds and thousands of edge locations versus a few central locations. One other large technology hurdle that we'll need to take care of is also the need for some sort of data consistency across all the locations, and perhaps we'll be turning to things like data lakes to bring this to fruit. So with that, I'd like to pass the floor over to my colleague, Alan Hu, to talk to us a little bit about some of the challenges with SDN and why that's not enough.
All right, okay. Thank you, everybody. Yeah, actually, good morning and good afternoon, depending on where you are. My name is Alan Hu. Actually, I come from Huawei Technology. It's a product line focused on IP routing. And actually, today we want to give some updates from Huawei side, what we are focusing on from now, maybe a few years later. If you check like by today, right, and we face top 3 challenges, especially driven by 5G and telecom cloud. And as like Cliff mentioned, SDN come out maybe 5 years ago. And at that time, probably we haven't talked too much about 5G. We also didn't talk too much about cloud, especially telco cloud. By today, you see the top challenges based on our interaction with the global customers and the 3 big challenges. The number one, if you think about 5G, like one of the big services called EMBB, they need capacity. They have to increase like 10 times capacity, but meanwhile, they want low capex. So that means they need to address the big capacity growth with a minimum cost. That's the number one challenge that we'll see. The second one is we call flexible connection. Actually, that will become very complex if you compare with previous. As Cliff mentioned it, telco cloud, they have like compute to, if you think about it, if you think about distributed telco cloud, all the elements, no matter it's VNF or whatever, they need a connection. So they need a connection is not just the physical devices. They need to connect between physical devices and the virtual environment. That means we have to address this. This is another big challenge for telcos. The third one is operations. You think like traditional operations, they're not happy with it. Typically, you know, like customer complain, they generate tickets, and they take like weeks and months to fix it. Right now, they don't want to this way continuously. They want to say transform the OpEx from like reactive mode to preactive mode. These are kind of 3 are the top challenges. But if you check SDN, I would say that 5 years ago we come to SDN. We mainly focus on what? Focus on distributed and the controller and the separation between control plane and plane. That's the kind of SDN origin come out. But they're still valid. But if you see the big 3 challenges, SDN cannot solve it entirely. They can solve it partially, right? If you think about the network, today, when we build a network, we still major focus on network. We call network-centric approach. But moving forward, we want more is a business-centric, more customer-driven, and SDN cannot solve that. And another one is the fragmented network. It means the physical devices and virtual environment, how to build the synergy and connect to them each other in very dynamic, flexible way. That's another, today's network, we cannot easily solve it. Operations, I mean, we need to move from reactive mode to proactive mode. This also SDN cannot really easy to fix it. And also that if you say we still depend on other skills, we need the intelligent embedded in it to add the automations. That. So I would say, if you think about the last couple of years, most of the buzzword talking about is AI, tech and machine learning. They apply a lot of field. So we also industry think about in the telco space. As long as we face a lot of challenges, can we leverage AI? Can we leverage machine learning to improve the operations, improve the OpEx efficiency, and more intelligent on it? So that I would say is a key point, how to moving forward to leverage. So before I moving on, I want to give back to Cliff. We'll maybe pose some questions about AI and machine learning. Okay, Cliff, can you take back?
Thank you, Alan. And I think it's time for us to see if the audience is up for a question, and we're asking you to help us out. We'd like to understand perhaps where you are in your journey to understand AI techniques and maybe apply machine learning for closed-loop automation. And you can choose between having already deployed. So even if we're in the end in December, so if you're deploying this month, you can check already deployed. And then, are you doing it by the end of 2019 or 2020 or 2021? You see it as a 2022 or later, perhaps you don't know, or you're sure there's no plan for your organization to look at AI and ML. So as I give the audience just another minute or two to answer, I'd like to take the time to remind everyone that there will be time for questions at the end, and you do have a place in your console where you can put in questions. So please go ahead and think about any questions you might have and add those to our board, and we'll get to them at the end. So I think we have enough time passed. Let's take a look at what the responses were. Okay, well, this is not too surprising. In fact, with 11%, I actually think there's more people that have deployed than I would have imagined. And a good amount of people, 17%, said they would deploy by end of 2019. In 2020 are pretty equal. So the next 2 years, it looks like, are going to be the years where we see a large uptake. And then there's a lot of people who still don't know. That also makes sense. I think the results we have from our own surveys would match this, that there's some that have deployed. The next 2 years are going to be a watershed time when AI and ML go mainstream. And then there's a lot of decisions still to be made. There's a lot of people who still are looking at things but haven't made any decision as to when they will plan. At this point, I'm going to push the floor back over to Alan and ask him to talk to us a little bit about some of the potential solutions.
Okay, yeah, let me take it back again. So maybe I can give you a little bit update. Is like, first of all, like from industry perspective, right? What's the AI and machine learning role in the like OpEx and the automation side? So we have a new term called closed loop automations. So before I jump a little bit detail, let me give some like new term. I mean, it's maybe called new technology called digital twin. And digital twin, if you're not like in maybe manufacturing space, maybe automotive space, you are not very familiar. But I do like start a little bit. Is digital twin actually is considered as a very important technology moving forward. And what means digital twin? Digital twin means like you duplicate the physical world. You create a real-time called digital replica of the physical world. And it based on that maybe some data like sensors collect the data, they form up like one digital twin. And once you have digital twin, then you can integrate it, the artificial intelligence, machine learning, or big data analytics to process this. So, and this concept, I would say this technology are already applied in the manufacturing industry. And recently, a lot of IoT applications also leverage this called digital twin concept or digital twin technology. If you move into the industries like General Electric, like Siemens, like Microsoft, Oracle, all these guys try to leverage this technology to apply IoT applications in the healthcare industries, factories, etc. Now we are in the telecom space, right? We also facing a lot of challenges in operations. Can we leverage this technology and apply to maybe tackle operations? We say yes. This is the Huawei says, and the industry also looking for this kind of approach. Can we build the digital world on top of physical devices or physical network and create some kind of digital twin? And then we can, based on digital twin, do a lot of innovations. If you say the industry peers, if you check other vendors, they pretty much look in a similar way to use AI and machine learning to do user-centric approach instead of network-centric. And automation, typically talk about automations, probably talk about end-to-end service provisioning stuff. Now that we call closed-loop automations, we can leverage this digital twin technology to do it. And proactive OEM also can be achieved if we have like a digital virtualized, I would say, data-driven network. And we do have a lot of new technology can enable it. If you compare this one, the three key technologies, combine them together, can make it happen. Number one, you need data. You need real-time data. So right now we have, if you check networking space industry, right, we have something called telemetry, streaming telemetry. That's a kind of protocol can collect the data in real time, pretty much, second levels. And once you have lots of data, and you can use AI or machine create modelings, and then you can apply to a critical virtual world, digital world. Once you, based on this, do some analysis, take some actions, then SDN jumping can make it happen. So this is the idea of philosophy in the operation side. I would say we see this is, I would say, the game change in the telco operations if we really can implement it. And from Huawei side, we go in these directions. We jump over from SDN to SDN plus. We call SDN plus. Plus what? Plus intelligent. Plus more like big data analytics and to drive operation moving forward. And here, Cliff, you want to talk about the slides, this one?
Yes,
maybe you can
thank
you know more than me, yeah.
Thank you, Alan. That's great.
Yeah.
And what I wanted to do also is share with the audience a new analysis that we just finished at IHS Market. Coming back to our question about AI and ML, in the use of AI and ML, we set out to understand within the server market, that is, this is looking at server units shipped, and looking at co-processors that are in servers designed to accelerate AI and ML. So this could be co-processors like GPGPUs. It could be specialized circuitry based on FPGAs. It could be Google's TPU. And there are some other very small co-processors. What we see is that today, or in CY17 or even CY18, we still only have maybe 2% of servers shipping with a specialized co-processor for AI. However, we expect that to jump to just over 10% by 2022. About 1.6 million units, that is million servers, will ship with some sort of AI and ML co-processor in it. And some people may look at this and go, wow, that's not very much, only 10%. And here's the case where we have hype and there's reality. And what I can do as an analyst is tell you that going from under 1% in CY17 to over 10% in CY22 is actually a pretty good jump in terms of the growth rate, and you can see it visually. It looks pretty healthy. And typically, once we get past that 10 to 12%, that's when we like to think of a technology as hitting mainstream, crossing the chasm, if you like. And at that point, it typically tends to accelerate. So this is our forecast on what we see in terms of the silicon needed to support AI and ML going forward. And this silicon will be in servers that will be distributed in all sorts of data centers, all the way from a centralized data center to the edge. Okay, well, with that, I think I'm going to turn it back over to Alan to talk a bit about the Huawei approach.
Sure. Actually, I plan to spend like 15 minutes, a little bit, around 15 minutes, to explain to you a little bit detail on Huawei side how to implement the future network. Okay, we call intention-driven network, called IDN, and the term come from like 1 year ago, but we keep adding the new stuff. It says we leverage intent-driven and to drive the business values. As I mentioned it, we try to think about how to create the digital twin. This is number one, we have to do it. And once you have digital twin in there, then we can build some intention-driven. That means moving forward, your network will be the business-centric or experience-driven instead of purely network-centric. And if you check the slides, we put it like 3 stages. Right now, telco environment operation network is very complex, especially you think about 5G coming. If you check about telecom cloud, and the network typically is build a network connection. Right? Once the connection devices become very, very sophisticated, then we have to add more intelligence on it. If you check like 1 or 2 years back, we more focused on SDN, called software-defined network, and today, and we more focusing on is SDN plus intelligence. And if you check here, once we can build these foundations, and from our like company visions, moving next step, that will be called autonomous driving network. It's like autonomous driving car. Once you build a network, and if you apply some like right policy, then you can release your human forces and let the automatic adjust the network and make it like a robot running there that can fix the network problem by itself. This is pretty much is our approach. We will slow like SDN, evolve to today's network called intent-driven network, and moving forward, we will try to evolve into autonomous driving network. This is pretty much a 3 stage we are keep working on it. And one thing, when we talk about Huawei, talk about IDN network, intent-driven network, and we always mention one called platform, called NCE. We internally, we call it Network Cloud Engines. Why we call it? Because this is a brain, is a kind of central brain for Huawei ID. And if you check this platform, this is a Huawei, we put a huge R&D effort. Pretty much is 1,000 engineers working on this platform, try to build intent-driven network. And I would say this is the platform, okay? The platform, they have multiple key components here. If you want to implement that called closed loop automations. If you check, they have like 4 engines inside. Number one called intent engine, which means like if you have some business intent, this guy will do analysis on your intent. And your intent, if it's valid, they can convert it to intent to the natural language and apply automation engine. It typically is SDN apply on it. And once you have automation engine applied, they can really touch your physical device, make it happen. But once make it happen, is this really valid, right? They have to verify it. And they have pulled the data from real-time network and pull data and then have intelligence to AI or called machine learning analysis. So the 4 key engines composed to this NCE, okay? And also this platform we call cloud native platform. Why we call cloud native? Because we build this product based on microservices. That means we can, based on this, chunk to the, typically the one business services, chunk a lot of microservices, and then we can really do called programmable automations. That's another key for this platform. And all this behind it is what? Is a physical world we call digital twin. So these guys will pull the physical device, physical logical topology, will real-time collect the data, and then build the model and call digital twin. Then we apply AI, apply like machine learning, and to add more intelligence. Then they can implement called closed loop automations. We will say this is the key. So meanwhile, we have another element is when we have this product, eventually we have to apply to the customers how to use this. So we have one tool called Design Studio, also is a part of this product, and that give like interface for customers how to easily to build a model, apply to leverage this one. Okay, so open is also the key. We have northbound, southbound open, and also we create a lot of use case based on the product. So I would say that's the key for this intention-driven network. And if you check this, the slide, I'm showing you automations. We get right now stages called NCE 2.0. And if you look back, like 2016, at that time, we try to do is what? Try to do controller plus called network management. We don't have intelligence in it, right? And then later on, we evolved the platform to add the more openness. And last year, or this later last year, or this year's, we really implemented this as intelligence, more because the fundamental for IDN. So this we go to the market, and also we go to the customers, explain them how this platform works. And then by today, we can implement some closed loop, but our is not perfect because every new technology you have to implement it, deploy it, and to verify it, right? So now we have to say, we can do it. We try to identify customers to prove it. It really can bring a benefit to the customers. So we can do pretty much the management, controllers, and analytics together as a one product. And also this product is a cloud native, and also it have open API for third party. We can build third party applications based on this product. That's, I'll say, is very fundamental for our IDN solutions. And program automations, that's tool we call Design Studios. Design Studio pretty much is the face for customers. We are training customers how to use NCE platform. And we built a lot of microservices. If you think about, if you familiar cloud computing actually chunk a lot of function as a micro function or microservices, and then you can easily to use it. So we pretty much use a similar logic is like NCE, maybe they have some microservice can run in just a statistics, maybe can do troubleshooting, diagnosis, this kind of micro functions, and then depends on customer what they wanted, right? If they want to analyze the network, they want to troubleshoot in it, they really can use the service model driven to build the, I would say, applications like to running over NCE. And also we support third-party algorithm and applications running over it. So these are called programmabilities. And we have some like application cases, especially for 5G backhaul network. We can do programmable, very easy to add this without human engage. So once you use this product. And this already used by like certain customers that feel very happy about this kind of programmable capabilities use Design Studio. And closed loop, as I mentioned, how to implement closed loop? If you check here, the number one element is streaming telemetry, because you need the real-time data. Once you build a digital twin, you really need real-time synchronized with the physical world. Otherwise, if you build an intelligent application based on digital twin, this digital twin not synchronized with the physical world, you'll fail, right? You cannot do it. So we need real-time networking data from like physical side based on telemetry. I would say why we can do digital twin, because we have some new technology. Streaming one of protocol very important. Another one we call BGPLS. If you know the IP network, they really can pull a lot of topologies. So once we have topology data, we have like a real-time network data, we have devices data, and we use model called 5-level model called OPM. This is modeling. Then we can build like a similar world, like a physical size. And then based on that, we can do a lot of innovation using digital twin technology. So I would say streaming telemetry is the key, and all the Huawei devices, all the have embedded can really have capability to send the data, push the data out to NCE devices and NCE use the modeling to rebuild this like physical world to as a virtual side. Then we can on top of it build an application on it. This is also how Huawei to implement we call closed loop, because they will based on the OPM model to build a digital twin, and based on that we use some algorithm to generate a lot of application on it. And if you remember like the first slide, there's a top 3 challenges. Sometimes we cannot always address intelligence on it. The number one is the capacity growth. So when we talk about idea network, is intent-driven network, yes, that's more like intent-driven. But for the 5G comings, they need a capacity, right? They need, because you have a lot of video applications running over like VR, like cloud computing. They need a capacity, and they need a capacity from our equipment side. We can build a capacity. But the challenging part is how to build the capacity, boost the capacity in the cost-efficient way. We say the minimum cost. So from Huawei side, we are equipment vendors, right? We try to do our best to address this called exponential traffic growth, follow Moore's law. If you say Moore's law, if you're familiar from like semiconductor industry, they're talking about every 2 years, like a device or one chipset that put a lot of transistors in the same cost. In the network industry, we follow the similar logic. Is can we add a capacity every 12 months, 24 months in the same cost? So this is what we try to address. We can address is for the IP routers. We can do every 2 years double capacity, same cost. For the OTN optical side is a little bit longer. Is maybe every 3 years we can double capacity with similar cost. And for like a PON side, the access side is every 4 years we can double capacity, but with similar cost. But we still say we try to follow Moore's law to address the capacity demand. And that is the one side from like typical for the equipment side. And we also think about is architecture levels. And we talk about a lot of intelligent engineers, but once, as you mentioned, is we need re-architecture our network, make sure the network is more scalable, more easy to expand, to address, I would say, capacity growth of the new services. If you remember, like Craig mentioned, there's a famous sentence is, if you automation based on inefficient network, that means it magnifies the inefficiency, right? So we have to simplify the network first, then we can add automation and add the intelligence on it. That makes a lot of sense. So how to simplify the network, right? So we, from Huawei side, and we work closely with global operators. We also support a lot of the data center environment. And if you check last few years, the OTT doing very good on their data center architecture. So we are also thinking about, is there any way we can leverage OTT practice and to build the telco network use similar logic. So we say the fabric architecture is a way can simplify at least is underlay network. Can we leverage kind of DC fabric style to build the telco network? So we call modular fabric. We can standardize the fabrics. This is what we are achieving. So we will go to fabric architecture, number one, and also we leverage modulation solutions and standardized solutions formula follow like a DC practice. This is we can say is architecture simplify. And the second part, we try to working on called decoupling. Decoupling means what? Means like underlay network and overlay network decoupled. That means you can add more agility on service layers. And how to do it, right? So today, we think we have to simplify underlay network use fabric. We have to simplify on protocol level, especially for IP network. We have to simplify, we leverage some new protocol. And from Huawei side, we emphasize segment routing. And especially segment routing V6. And we think about segment V6 is a very great protocol, can simplify protocol levels. And then we can decouple the service layers and underlay fabric physical layers. And also the easy to scale. And segment routing plus another protocol also very important, can simplify, called EVPN. So moving forward, how to simplify network, make your network more scalable. We do fabric architecture, and we use segment routing or segment version 6 plus EVPN. So we get rid of a lot of like legacy MPLS protocol or legacy like LDP, MPV, and simplify protocol. And then we re-architecture network, make it more easy to scalable. So this is our approach. So if you're looking back, we will do architecture approach, architecture simplifications, and we follow Moore's law, and we add IDN driven, so we can make intelligence on top of a simplified network moving forward to address challenges. And as I mentioned, this is pretty much our approach. And next session, we talk about some practice. Before I moving forward, I will give the clip back from analyst perspective how to do automation on re-architecture network. Right? When we simplify network, we actually based on that how to add on automation on it. So Cliff, can you take back?
Yes, thank you, Alan. And what we wanted to share with everyone was our architecture for network automation that we see being implemented in the telco network. And it all starts from the different devices in a telco network, and we have many, many domains within a telco network. It's a very complex network. We have mobile domains, we have the broadband, we have the WAN, we have also different types of services for business VPNs. We have optical transport networks. And all of these different domains are going to have separate orchestrators. And what we're going to need at a higher level is an orchestrator of orchestrators where we understand the services that are being delivered cross-domain and have service models and a map for that. We then would have device models so that we could program the devices on the fly as needed by the different services we want to offer. Then, of course, we're going to have instrumentation through SDN controllers that is going to gather data and feed it back, giving an idea of how subscriber behavior is going and instrumentation on how the network's performing. We'd use some sort of real-time analytics, perhaps small data, to locally process what we need and perhaps make some real-time adjustments. We'd also feedback that small data the data that's been processed to policy infrastructures, looking at what was the quality of experience and what is the SLAs. And then, of course, we have input back into the OSS BSS systems, very much creating a closed loop to deliver the cycle of automation we talked about. And one of the things that I didn't mention a little earlier is that fed into the orchestrator of orchestrators would be the idea of intent. So the orchestrator would have a depiction of what is the intent of the service designer, which it could use then to implement policy. So with that, I'm going to pass the floor back to Alan to take us through some case studies.
Sure. Okay. Thanks, Cliff. Actually, on Huawei side, last year, this year, we tried to focus on how to identify some business case, and we can bring idea and engine-driven network from just maybe just talking to real deployment. And we create one called Net City, is kind of a joint innovation model, and we try to identify our, from like a strategic customers, we identify the case. And here, I give some numbers here. I was told I won't release any customer name here, but I just give some ideas what we are doing now. So we identify different scenario, and from like intelligence-driven GPON network, FTTX, and optical network, IP, data center, or even like campus network. So we do have on each area, we work on some different customers to identify what kind of business case they are. So the basic goal is we build the platform, and we build this product, try to solve customer issues, try to maybe improve the operating efficiencies. But different customers, they have a different pain point. And then we have to work at different, I would say, scenarios, leverage this called NCE, and to work on different cases. We cannot build one product, apply everything, one time, one size fit all. This is not work like that way. So one example is typically take about like 6 to 9 month cycle to finish some like maybe some case studies. And if you check, we do have some cases like we work on the fault detections, and another one is how to maybe have them solve the main pain point. So this gives you idea is we do practice, find the streetcom practice idea networks so far. And one case studies, this is I'm telling you from one customer apply called AI powered, maybe called proactive maintenance. We do see the result. If you check, and we use called NCE is a partial functions, not the whole NCE function that is applied in this case. We do apply some closable functionalities like apply optical network. The result, if you check a compare result, we can improve called ratio, failure identification ratio improve from 30% to 80%. Okay, that's a lot of improvement. And also we improve like for ticket creations, and from 3% to 20% plus. So that means this can tell you is we do see the benefit if you might transform our maintenance operation from reactive to proactive. This make a lot of sense, really can bring the benefit to our customers. And then lastly, let me quickly summarize. We see the called IDM. Why we doing IDM? And we want to maximize your business value. Bring the benefit to do it. How to do it? Okay, we will build the network, typically called network-centric, from network-centric to user-centric. And we use what? Use called digital twin technology to do it. And the second one, we will use AI technology to enable automations and do proactive maintenance instead of reactive maintenance. We already seen the cases can benefit customers. And we will continue to address called Moore's law in the network industries. We want from equipment innovation, and also we will re-architect your network, maybe from protocol levels, also from underlay of networks. We use fabric architecture to simplify network. We simplify protocol to address Moore's law. And also we use a connectable city innovation model to engage with customers and bring idea from vision to deployment. This is our continue to go into the effort. And if you have interest, and maybe we can work together to identify some cases and to see the benefits idea can bring to you. And with that, I'll back to Cliff to give the summary about this one. All right, Cliff, can you take back?
Thank you, Alan. And I just wanted to wrap up with everyone. I wanted to remind everyone that if you do have a question, please enter it. We will have potentially time for a question or two. I wanted just to remind everyone that we took a look at edge computing to start with. It's going to be a highly distributed environment, and that can only be achieved with automation. It'll be impossible for humans to manage all of that in real time. We also looked at intent-driven networks and understood how that's an imperative for automation, as intent will be a key element of understanding whether or not the network is behaving appropriately. We understand that also part of the technologies we're going to need to introduce include AI and machine learning and creating a closed feedback loop. It's the only way we're going to manage, monitor, operate, and control hundreds and thousands and maybe tens of thousands of edge locations if the view or vision for edge compute is to be realized. And we also see that while there are applications today already that provide some elements of edge compute, going forward as compute gets more powerful at the edge, we're going to see a lot more applications that can provide a far more immersive experience for everyone. So with that, I'm going to open the floor to questions, and I'm just having a quick look. I do have a question here, and the question here is that the introduction of AI and ML automation will certainly introduce some unpredictability and risk. And the question to you, Alan, and people at Huawei is how will you protect the network from some sort of risk with AI and ML as you introduce a new technology?
So can you repeat again? How to protect the network?
How to protect the network from outages as we introduce AI and machine technology, which is a technology that has some unpredictability to it. It's not totally predictable, AI and ML.
So, actually, right now, as I mentioned it, if you build like a virtual code digital twins, actually try to duplicate the network, and if you can real time collect the data from the network, right, and then can go proactive, they can protect the network before its failure. That's we can do. You do not need human engage, and once you have some potential failures, and they can actually need maybe microsecond stuff and don't need a human engage. That's the beauty of AI or machine learning. We can use closed loop. So this is, I would say, the big improvement on this called network failure protections. They can proactive to do it instead of reactive. And if you say how to do it, we do use called NCE, and we can real-time data second levels and to do protections.
Yeah, I think that certainly proactiveness makes a lot of sense to me as well, Alan. And from my background in AI, one of the things that we always did as we started to develop autonomous systems is that we had large periods where they were shadowed by humans. So we didn't just let them go. We would have AI, we would have AI systems predict or suggest a change, but have those changes approved by humans until we had a pretty good understanding that the AI system would be better than humans. And we also have to remember that even humans will make mistakes. And we, of course, want our AI systems to be at least as good as humans. But if we hold them to too high a standard, then we defeat ourselves. And I've seen that happen in the past as well. We have a few more minutes left, and I have an interesting question. Alan, maybe you can help me with this one. This one was asking about NCE, and can we run that in a cloud environment such as AWS or VMware Cloud?
The answer is yes. And right now, NCE, we build the platform, and if you deploy right now, we can run on different public clouds, include Huawei. Typically, Huawei has our own cloud platform, and we can run it on top of it because this is built on top of container-based or VM-based. We can run different environments, cloud environments.
Okay, well, that's interesting because I've heard lots of discussions in the carriers that I've talked to about wanting to use the cloud for some compute that rather than always buying every piece of equipment themselves and paying a CapEx expense. Okay, well, with that, I think we're going to close the webinar for questions, and I'm going to pass it back to Alan Tatara for a quick wrap-up.
Thank you, Cliff, and I want to thank everyone for participating on our webinar today and for submitting your questions and comments. I also want to thank Cliff for leading our discussion today, as well as Alan from Huawei for sharing your expertise with us as well. So an archived version of this webinar will be made available shortly, and we'll be sending you a follow-up email on how to access that archive, or you can simply use that same audience link that was sent to you earlier. So feel free to come back again, view this session, or even share it with your colleagues. Now you will see a short survey that will pop up at the conclusion of our webinar. We'd love to get your feedback, so please take a few moments to fill that out. And please continue to follow us on Twitter and LinkedIn for information on future IHS Market Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.